We have discussed various integrations with the LangChain, LangGraph frameworks and all. But have you ever considered integrating it with a Pandas DataFrame? Pandas is one of the very important tool in the machine learning world. We can manipulate or process or filter or create, delete and update the data according to our business requirement. Pandas can communicate with the Excel sheets, CSV formats or SQL databases and text formats and many more. It can visualize the data by combining with a matplotlib. Today we are going to consider a use case which our LangChain framework will integrate with Pandas and our natural language would be able to extract the data from a Pandas framework. This is Melvin Satishan, and without wasting much time, let's move on to the workshop. First, we have to open a Python notebook. In that, we are using 3.9.6 kernel. Let's open a cell and import the necessary Python modules from LangChain .agents .agent types import agent type from LangChain experimental .agents .agent toolkits import create Pandas DataFrame agent. Next is from LangChain Ollama import chat Ollama import Pandas as PD. All our modules are imported. Next we have to create the LLM base underscore URL equal to http://localhost:11434 and model equal to llama 3.2:3 billion and LLM equal to chat Ollama base URL model. Our large language model is ready. Next we have to create a Python or Pandas data frame df equal to pd dot read CSV. Here we have to define master data underscore CSV. Our data frame is ready. df dot info. It provides us there are total 27 columns, so total 28 columns somewhere, and we have 1000 incidents. Perfect. Our next step is to create an agent, right? Agent equal to any variable you can provide it. It's not a big deal. Create Pandas data frame agent. First thing we have to provide LLM. Second thing we have to provide the Pandas data frame. Next we will see verbose equal to true, so that it will run in the debug mode. However, we will get some errors. Let's see and identify that. This agent relies on access to a Python replication tool which can execute arbitrary code. This can be dangerous and require so please read the security notice and what is expecting. Allow dangerous code, because this Pandas code may write dangerous codes like create, delete and update in our frames. So we have to do our prompt engineering accordingly. We will come across couple of scenarios. We will discuss that later. Now we need to understand various tools that can be used with the LangChain framework, specifically the built-in tools. So our life will be much more easier rather than writing our own codes, right? In this case, all we need is to provide that particular switch. We will provide it. Let's execute it again. Our agent is ready. Response equal to agent dot invoke. Here we have to provide our query in the form of natural language. How many low priority incidents are there remove the limits if any, because the database by default, the LangChain query will provide us just 5 rows, but we don't want that limit. It should print everything, right? And additionally we will print the response as well, so that we will get all the things. And we are executing it from top to bottom. And one more thing I would like to let you know is agent. Agent is a component which is intelligent enough to extract the content from our natural language that we provide as input, right? From there, it will assemble the functions, then it will execute it into the database. Then it will assess the response, and it will do, if there is any modification is needed, then it will reiterate over the database again. Then it will get the final response. That final response will provide us. These all are automated in an agent. Okay, that's the beauty of agent. So similar thing is happening here. It is finding out the schema, it is executing, doing a lot of permutations, combinations, and it will be providing us the final response. It shows handle parsing errors to true. Okay, so in this execution, let us see what are all the options. In this agent executor, keyword arguments are there. It is going to be a dictionary. So let us mention that as well. Equal to, here we need to define the key. Key is going to be handle parsing errors, and that we would define as true. Here we need to define it true. Let's run everything once again and see how it behaves. We have received the final output. There are 309 incidents. The number of low priority incident is 309. Now one more thing we need to check. Let's figure out what are all the parameters in this department. For that, we will do df, then we have to define department. Let's say department. We have engineering, services, marketing, sales, and human resources. So we are going to filter out engineering division. How many low priority incidents are there in engineering? Okay. And we will run everything once again. If you look at it, it's doing a lot of adjustment. The number of low priority incidents in engineering is how many? 24 incidents. The above response, our agent performed multiple iterations. It performed a lot of corrections and reiterations. Then it obtained the final response. This way it works. We will look into many more built-in tools. Rather than writing or developing our own tools, if there's a default tool is available, we can happily use that and save our time. That's it for now, and thank you so much for your time, and wishing you a great rest of the day. This is Melvin Satishan signing off. Thank you.